Okay, hello everyone. Welcome to today's webinar titled "The Current Use of the Nile Water and the Impacts of the GERD." This is the fourth of the 10-part webinar on the Nile River Basin in Crisis, organized by the UCLA African Studies Center and the UCLA School of Engineering. So today we are going to have three great speakers who are going to talk about each of the three Nile countries. Right after these three presentations, we are going to have Q&A. So please don't forget to add your questions into the Q&A box. Our moderator for today is Dr. Kevin Wheeler, who is a fellow at the University of Oxford. So without further ado, Dr. Wheeler, please take the mic.
Excellent. Well, it's an honor to be moderating this session with three outstanding speakers. Two I've met before, and one I haven't met yet, but I'm excited to learn more about his work. We're going to have Dr. Johannes Gebrtsadek speak first. That'll be followed by Dr. Adil Ibrahim Bushara Ahmed, and then finally Dr. Hani Suilam will speak. So we'll start with Dr. Johannes Gebrtsadek. His primary area of discipline is water resource engineering and development application of analytical methods, modeling, decision support tools. He's got a degree, his PhD from CU, University of Colorado in Boulder, my alma mater also. He's got his master's and bachelor's of hydraulic and civil engineering from Addis Ababa. He's been a consultant for several years for NBI and others. And I asked everybody one question. I asked, what is your hope and vision for the Nile Basin in 20 years? His response was strong institutional transboundary cooperation and regional economic integration, countries jointly implementing and operating infrastructure. I'll be curious to see how those differ between all the participants. So, Dr. Johannes, if you would please open your camera and start your presentation. We're honored to have you here.
Thank you very much, Kevin, for that nice introduction. I would also start by thanking Professor Makuna for organizing this webinar series. I think it's a very useful webinar. A lot can come out of it. So I think if you allow me to share.
Yes, you are a co-host. You should be able to share.
Right. Are you able to see my screen?
Yes, we are.
Okay, perfect. All right. So I can assume some of you are well informed on these issues, but it's important to highlight some of the developmental challenges Ethiopia is facing in both socioeconomic and water resources development dimensions, which are highly interlinked for Ethiopia. From the socioeconomic aspect, Ethiopia has high population growth rates, currently estimated around 115 million, which is expected to grow into 230 million by 2050 if the current growth rate continues. There is a high level of poverty, close to 20% of the population living under the poverty line. There's low access to basic services. The million people living without access to electricity, and close to half of the population without access to drinking water. And if you look at the statistics, the impact for people using safely managed drinking water, it's close to 12 to 13%, according to the statistics published by the World Bank. So although Ethiopia is rich in water resources, there has been some challenge develop the water resource. Again, there is a high seasonal and spatial variability. As you can see on these charts on the right, the middle shows the monthly distribution of flow in the major river basins. For example, looking at the Blue Nile, more than 80% of the water comes in just 2 or 3 months, and the remaining of the year is just a dry flow. So you can see how that would bring some challenge in terms of developing that water resource, and not only temporarily, but also there is a high spatial variability across the country. Therefore, that also has been contributing why Ethiopia has not been developing the water. And most of the rivers are transboundary, as you also can see on the map here, which has its own challenge. And there is a weak resilience in the water resource system in terms of dealing with variability and shocks such as climate, and also environmental degradation is prevalent. So if you look at this chart, this shows per capita water availability for Ethiopia, and you can see a steep declining curve. Even though the volume of water is not changing that much, there is a huge population growth, so the amount of water available per capita is definitely going to reduce. So I mean, for example, by 2050, in order to provide basic service for the estimated 230 million people, or even just maintain the current level of poverty, it's imperative for Ethiopia to engage in developing its resources. That's why GERD is a very important milestone in Ethiopia's quest for developing its water resources. So looking at what will GERD ultimately bring to the table. GERD is not it's not really a political statement, and it will never be used as such. It's a project meant to provide the people of Ethiopia with much needed support in their struggle to get out of poverty. It's a regional project in the sense that the benefit is not only for Ethiopia, but also for the downstream countries as well. So there are, I mean, it's a known fact that electricity consumption and economic growth are closely interlinked. There's almost a direct correlation between available energy and electricity supply and economic development. So growth will not happen without some sort of steep change in the power sector, and it's not just to lit up houses, but really unlock the potential of business and drive much needed industrialization to create jobs. And it generally has this cascading effect on the economy. Looking at the current power consumption for Ethiopia, it's only 69 kilowatt hour per capita per year. You can see in this chart that it's really the lowest for the majority of the Nile Basin countries. And this 500 kilowatt hour is a threshold specified by the UN as the minimum energy requirement to achieve substantive development, expand industrialization, and expand trade. We are way far from that line. But when GERD is completed, it will provide close to 15,000 gigawatt hour per year, which will bring the per capita availability of power from 69 to 220 kilowatt hour per capita per year. That will at least bring Ethiopia close halfway to that threshold line, in addition to providing affordable energy to the public. So you can see how really important it is for Ethiopia in terms of driving its economic activity. But it's not only for Ethiopia, really. Like I said earlier, there are multitudes of benefits for the downstream countries as well. There's an energy uplift, water saving, in terms of adapting to changes in the future, whether it's a natural variability or a climate change. studies published are showing an increase in Sudan's power generation capacity after GERD is completed, simply by the virtue of regulated flow downstream. Here is a figure that I put from one of the studies, which indicates 2,600 gigawatt hour per year in energy generation boost without any additional investment. Just because GERD is there, Sudan will be getting additional energy, and also it's an opportunity for additional projects, hydropower projects for runoff river plants, and creates an opportunity for power interconnection. Really, I do not want to get into details into these things. There are a lot of publications to support this, but the point I'm trying to make is that GERD is beneficial for the downstream countries, and it has been acknowledged actually during earlier time of the project. In fact, Sudan was very enthusiastic about this project, and in fact, Sudan supported Ethiopia during the earlier phase of construction. So it's a regional project, the win-win for everyone. Now, I'm going to go ahead and make a bold personal statement. That the issue of GERD is rather the easiest challenge that countries are having when it comes to the Nile water utilization. And I'm not saying that in order to undermine the challenge, but primarily because GERD is an unconsumptive project, and in fact also beneficial for Sudan and Egypt, like I have said before. And secondly, a significant portion of at least the technical issues have been more or less reserved. And I personally think and believe that the remaining issues can be resolved as well with further dialogue and discussion among the countries. But most importantly, the issue of GERD is, even if issue of GERD is resolved at this point, the upstream countries are going to continue planning and implementing projects to use or utilize the Nile river resource. So I put the three maps for those of you who have not been following up on the Nile issues. So on my left here, you have a map showing the water infrastructures. The red dots are showing the existing dams and hydropower facilities, and these green areas that you see are irrigation developments. Of course, there are upstream irrigation development, but the areas are really negligible. The majority of the irrigation is, or the consumptive of use of water is in Sudan along the Blue Nile and White Nile, and a large proportion of it is in the irrigation scheme in Egypt. On the middle is a runoff coefficient, an indicator map to show you where the water is being generated. So most of the water is being generated, the runoff is from the highlands of Ethiopia and from the equatorial region around Lake Victoria. And of course, there is a little bit in the South Sudan. Actually, there is a considerable runoff generated at South Sudan, but it joins a swamp and it doesn't actually make it, much of it make it to the system. So these are some indicator values in billion meter cube per year to give you an idea of how much water is available where. So I think the message here is that you can see spatially where the water is being generated and the water is being utilized. So the issues of the Nile is, of course, a bit more complicated. But if I'm asked, for example, to explain it to, let's say, 10-year-old, a simplified version of that would be, look, downstream countries are using the majority of the water, and the system is fully stressed. By fully stressed, I mean almost all of the water is being utilized somewhere. And if you abstract, let's say, upstream, it's going to report downstream as a deficit or shortage without putting any value judgment, but the system is interconnected. So anything, if you touch upstream, it will be reflected downstream. And the two countries already have a treaty to divide the water among themselves without leaving anything for the upstream countries. The upstream countries, on the other hand, have been relatively less developed have not been using the water so much due to economic reason, political stability, and also nature has been kind enough to provide them with sufficient precipitation to do rain-fed agriculture. But now, with the increased population growth, improved economic conditions, the upstream countries are starting to develop the water and claiming for the right to use the resource. So in a nutshell, the upstream countries are asking for a change in the water utilization, but Egypt and Sudan, or the downstream countries, are claiming for the status quo to continue. So I know this is a huge simplification, but that's more or less the reality, right? And of course, the people of Egypt depend on the current utilization of the Nile. Egypt is a beautiful country built along the course of Nile. It's unimaginable to think Egypt without the Nile, as you can see here. It's all built along the course of Nile. And honestly speaking, Egypt has relatively efficient agriculture, and personally, I have never had any fruit more delicious than the ones I've tried in Egypt. So yes, the countries are aware that Egypt depends on the water, but at the same time, for Ethiopia, GERD will not be the last project. In fact, it's only one of the 4 major projects that are planned along that corridor of the Nile. For Uganda, the people are not going to continue to pay 250 shillings for kilowatt, while 31 billion meter cube of water is flowing out of their country into South Sudan. South Sudan would want to expand their irrigation when the country is politically stable. They're not going to sit and look at the White Nile conveniently flow in and out of their country while the people have no access to electricity or food. In fact, looking at their master plan published in 2015, they have planned for around 110 and 105,000 hectares of irrigation to come into the system. So the point I'm trying to make is that we have bigger problem ahead when it comes to the Nile, and it's better addressed earlier. So to give you an idea of what I mean, let's take irrigation, the largest consumptive use of water in the basin, and this is the current utilization of irrigation by country, which corresponds to 9 million cropped area, equivalent to 7 million equipped irrigation area. Well, the cropped is higher because Egypt irrigation is like I said earlier, efficient, and then sometimes there are double cropping, so the cropping intensity is close to 2. But again, the reason I put these figures is let's look at the planned 3.5 million and the potential 5. Of course, potential is arguable, but taking the average number, 5 million hectare identified by FAO and several other studies. Like I said, these are planned on a system that's already stressed to the fullest. So where is that additional water planning to come to the system? So looking at this study published by UMI, trying to get some projection of what these demands will look like for the different planned projects. The study looked at the master plans of the countries and collected data in terms of what's expected to come into the system, and just running that through a simple crop model will give us crop water demand. Looking at that, currently 84 billion is being utilized in the Nile for irrigation. Of course, if you put this on top of that, we are looking at 40 to 50 billion meter cube additional water into a system which is already stressed. So that's what I meant by the future is more alarming than the level of attention that the decision makers are giving it at this point. Of course, there are technical solutions on how to address this, but these solutions most of them involve a strong level of cooperation as a condition among the countries. I can mention some, for example, coordinated operation of the dam. This is an structural measure which requires communication and some level of coordination among the countries. So if there is the cooperation there, this can be used to save water. And also there is optimization of regional crops, for example. That is under the notion that some crops consume less water in some climate than in others. So if the countries have enough cooperation and sufficient level of trust, maybe we can take the crop to the other country, and the countries can find a way in which they can trade and share the benefits. So, but in order to implement those measures, the cooperation is not there yet, at least. And when I say a benefit, I'm not talking about just for the upstream countries. I'm showing you here one result of one study carried out by Mark Joland, an hydroeconomic analysis on the benefit, looking across the different level of cooperation and what it means for the countries. So without dwelling much into the figures, if you look at, if you compare low cooperation, partial cooperation, and full cooperation, you can see a clear improved benefit. This blue bar is actually for Egypt. And if you look at that in both hydropower and irrigation, it's showing that Egypt could actually benefit a lot from cooperation with downstream, with the upstream countries. But how can we do that cooperation? I think maybe we could start by doing some sort of realistic analysis of the potential future and try to do some comprehensive assessment on the trade-offs jointly. By jointly, I mean all of the countries sitting in one table together. And trade-offs not only really economic, but looking at political implication and how it will impact the livelihood of the people. Because everybody knows conflicts are very expensive and they take lives. So if we look at the futures, for example, are we going to go unilateral action by individual countries, which is bound to bring more conflict and riots in the region, or are we going to have deals project by project like we did in GERD? We have seen how intensive that negotiation process was. That are we able to afford to get into that kind of situation for every small and big project? Is that even possible or practical? Or are we going to have some institutional transboundary cooperation where we can resolve things amicably? I think this is not a difficult question, but the decision makers of the country should start to seriously look at this thing in detail. And to conclude and to tie that together with GERD, I think GERD can be a means for cooperation. GERD is an indicator for the change of water utilization dynamics, so to say, of the Nile. We've all seen how complex a negotiation process can be, even for something that is an unconsumptive water use, and majority of the technical issues have been resolved. So the process of this GERD can teach us something. The process can however, be steered into a constructive step towards some sort of bigger institutional transboundary cooperation and regional economic integration, or it can be taken as the beginning of a long standoff among the Nile countries who are forever married through the Nile and geographically, if I may quote the Ministry of Water of Sudan. And the country should start to work towards this cooperation. So my message is that the countries should use this opportunity and try to achieve some sort of inclusive or comprehensive agreement, whatever you call it, such as the CFA or an acceptable version of that into how to utilize the resource based on some sort of acceptable principle that reflects both fairness, at the same time responsibility not to cause significant harm to all the parties involved. And the cooperation is not only the best, perhaps the only way to resolve the issue that we are having on the Nile. I think with that, I will conclude my presentation. Thank you. Back to you, Kevin.
Okay, well, thank you very much. That was a good overview of the uses along the Nile and the Ethiopian perspective. And so next we are going to go to Dr. Ahil Ibrahim Bushar Ahmed. Dr. Ahil is also a civil engineer in hydrology and water resources. He has degrees from his PhD from the University of Trento, Italy, and a research scholar at the University of Connecticut. He has a master's in hydrology and water resources from UNESCO IHE in Delft in the Netherlands, and a bachelor's degree in civil engineering from the University of Khartoum. He's currently an assistant professor at the HRC, the Hydraulics Research Center in the Ministry of Irrigation for Sudan, and works as a consultant for a consulting firm in Saudi Arabia. When I asked him what his vision was for the Nile in 20 years, he said, "I hope the Nile Basin will be managed as one basin and will have a legal framework for managing the basin in a sustainable way for the benefit of the riparian countries." Good words from Dr. Ahil. So I invite you to turn on your camera and start your presentation, Dr. Ahil.
Okay, thank you, Dr. Kevin. Hello, everybody. Can you hear me?
Yes, we can.
Okay, thank you. Okay.
We don't have your presentation yet, but
No, I have just. Okay, my presentation is about the current uses of the Nile water and impacts of GERD. So I will focus on the impacts of GERD on the Jazeera scheme. So because Jazeera scheme is the biggest and is the backbone of the Sudan economy.
Are you sharing your screen right now? We don't see a screen up yet. I'm not sure if you have a presentation to show. So should be under the green button, share screen. Perfect. There we go. Now we're seeing a number 16 here.
You can see it.
You start your slideshow. Hopefully, have it there. Perfect.
Is okay.
If you just start the slideshow, we'll be able to. Yeah. Yep. Perfect. Right now, that's good.
Okay, thank you. So my presentation is about the current uses of the Nile water and the impacts of GERD. So I will focus on the impacts of GERD on Jazeera scheme. So Jazeera scheme, because it is the largest agricultural scheme, and Sudan largely depends on the Jazeera scheme. So the presentation by my colleague, Dr. Ahmed Sheikh, he also works for the Hydraulic Research Center, and currently he's working at the Water Research Center at the University of Khartoum, and myself. So first I will talk about the irrigation in Sudan in general, just to give you an overview of the irrigation in Sudan to have an idea. So the irrigated areas in Sudan amounts to about 1.89 billion hectares. The total investment is about $22 billion. The government schemes, because we have private schemes and the government schemes. The government schemes about 1.35 million hectares, and the private schemes about 540,000 hectares. So what are the irrigated crops? generally in Sudan. We grow cotton, wheat, sorghum, sugar, groundnut, vegetable, millets, sunflower, and other crops. So the total share in the GDP is about 42%. So that's why Sudan, we can say Sudan is agricultural country. It depends on agriculture to a large extent for its export to get about 42% of the GDP. So, where is Jazeera scheme? Jazeera actually is located in the central part of Sudan, between the Blue Nile here on the right-hand side and the White Nile, and the two Niles meet in Khartoum, and then forms the Niles and flows down to Egypt from the Nile River. So the Jazeera scheme is irrigated from Sinnar Dam here, Sinnar Dam, through two main canals. One goes to the Jazeera here, and the other part of Jazeera is Managil extension. So Jazeera, we have two parts, Jazeera scheme and Managil extensions. The irrigated Jazeera scheme is irrigated from Sinnar Dam through two main canals and is irrigated by gravity. And there is upstream dam, which is called Roseris, which is about 100 kilometers downstream of GERD. So we have three dams here along the Blue Nile. If we start from the GERD, then we have the Roseris and the Sinnar Dam. So here in Sudan, we operate the Roseris and Sinnar Dam together. So with the operation of Sinnar, so we operate that the water, we release all water goes to Jazeera scheme, and the water goes further down through the Blue Nile to Sudan, to the downstream cities of the Blue Nile. So here, this is the Jazeera scheme. So the focus is in Jazeera scheme. If you see here, we have this map of Sudan, and we have in the central part of Sudan, we have the Jazeera scheme. So we'll talk a little bit about the irrigation system. We'll give you an idea how we manage water in the Jazeera scheme. What are the institutes managing the water in the Jazeera scheme? We have many institutes within the Ministry of Water Resources. And what are the responsibilities of each institute? So we have the Water Resources Directorate, so which measures the flow at the downstream Sinnar Dam. We have all dam directorates, which is responsible of releases from the dam. We have Irrigation and Operation Directorate, which is responsible of operation and maintenance of the irrigation system of the Jazeera scheme. We have the Hydraulic Research Station, or the Hydraulic Research Center, which carries out the calibration of all hydraulic structures and also monitor the sediment in the Jazeera scheme. So we have also the Mechanical and Electrical Directorate, which carried out the maintenance of all hydraulic structures and the mechanical parts and the operation and maintenance of pumps. So we have the project directorates, which design a remodel of irrigation system in the Jazeera scheme. So the irrigation system in Jazeera scheme is divided into 23 offices. We have 13 offices in the main Jazeera, because we say Jazeera in general is divided into two parts, main Jazeera and the Managil extension. So 13 offices in main Jazeera and 10 offices in Managil extension. And every office is headed by an assistant divisional engineer. A group of offices is headed by a chief engineer. The main Jazeera is also headed by a director, and the same for the Managil extension. The general directorate is headed by a general director. So this is the irrigation. This is the irrigation map of Jazeera. So we have here Sinnar Dam. Then we have two twin canals, which is Jazeera and Managil. And this part is for the Jazeera. You can see how many, how extensive we have canals, and we have branches, and we have majors and minors. All these are composed the Jazeera scheme. So we have really a complex scheme, and then managing such scheme is really a challenging task. So this schematization. So we start here from Sinnar Dam. We have a Sinnar Dam, and then we go here. We have a Blue Nile. We have two canals, Jazeera and Managil. Then we have Kilo 57, which is 57 kilometers from the Sinnar Dam, and then along this way we have the regulators. We have regulators which regulate water for the Jazeera scheme. We have this schematization, and we have here the regulator and the downstream view of the regulator. And we have this in the left part, we have the schematization for the Managil scheme. So we'll talk about the irrigation and drainage networks of the Jazeera. We have two main canals, which are Jazeera and Managil, with the total length of 261. And we have branches, about 11 with this total length. We have majors, and then about 107 with 1,652 kilometers. We have minors, and then we have drains and Abu Ishrin. These are the upper system. So which are the hydraulic structures available at the Jazeera scheme? We have rural sluice gate with this size from 2 to 4 meter with this number about 60. If we go also further down, we have rack and warm gate, wellhead regulator, butcher movable weir. We have pipe regulator, night storage weir, partial flume, fixed weir, field outlet pipe. So it's really a complex scheme that we can manage to have a better water management for the scheme. So I'm going to give you just here an idea. So this is a sluice gate regulator. This is upstream view. And this is a sluice gate for a regulator for downstream view. And then you see that the water released, and then you see the turbulence of water. So here, I'm just giving you about the typical water and sediment inflow at a dam gauging station. Then you see here in blue, we have the discharge, and the discharge start to rise from July, and then drops here to a minimum in October, November, and we see the sediment here also follows the same patterns of the discharge. So we have the same behavior of discharge and sediment. So the higher the discharge, the higher the sediment load. So we see here the discharge in million meter cube per day and the sediment load in million tons. So we measure also the sediment concentration at the off-takes at the Sinnar Dam, which we have the two canals. And then we have the concentration here, sediment concentration in Jazeera main canal. And here the sediment concentration of the Managil main canal. So Jazeera main canal, which irrigate the Jazeera sub-scheme, and this irrigates Managil extension. So if we plot the sediment concentration in these two canals, then we have strong correlations, which means that we have more or less similar behavior of sediment and same operation of the gates in the Sinnar Dam. So we here talk about the sediment load entering Jazeera scheme for the period 1995 to 2010. So we have here, for each year, we have the sediment load in 10 to power 3 tons. and then we have an increase to somehow, it's not strong correlation, but it's the figure showed the amount of the sediment entering Jazeera scheme. So this one of the real challenge that faces the management of the Jazeera scheme. So we go further, we talk about the deposition patterns of incoming sediment. So from the incoming sediment, we have about 5% that deposits in main canals, about 17% in major canals, about 38% in minor canals, and the rest, about 40%, passes to the field. So the amount that passes to the field is really huge amount, and it's very difficult to remove such amount of sediment from the fields. So just here to give you about the sediment removal. So when the sediment deposit in canals, we have to remove it. And then here we have the measured with the HRS, Hydraulic Research Station. We have the measured sediment, and we have here the cleared sediment. And you can see that the cleared sediment is higher than the actual measured sediment. So this is a photo how we remove sediment, and then once the canal get deposited with the sediment, then we have, you see here, we have these weeds, and we have this machinery also remove the sediment from the canals, and we that's also really cost the Sudan much to remove sediments from canals. So this is the same also how we remove the sediments from the canals in Jazeera scheme. So in the last part, I will talk about the potential impacts of GERD on Jazeera scheme. What are the positive and what are the negative impacts? So first we talk about the sediment, what's the positive and negative. Then we talk about the water supply and the damage on the scheme. So as I said earlier, the focus on the Jazeera scheme because it's the backbone of the Sudan's economy. So we'll talk about this, the sediment positive and negative impacts of water supply and damage to the scheme. So about the sediment, there will be a reduction of annual amount of sediment. So the total amount of sediment when the GERD is operated, then the amount of sediment will be reduced. So that amount of sediment entering the Jazeera scheme will be reduced. So what are the positives sides of this? So the positive, we reduce the annual budget of silt removal. So that's a positive effect of GERD. So what are the negative? So we lose the land fertility because when we don't have a sediment, we don't have a fertile land. We lose the brick industry. So people use the sediment for brick industry. So for the water supply, we'll have a sustainable annual water supply. So we have a sustainable water supply after the operation of GERD. So what are the positive part of the water supply? We will provide better options for crop patterns. So, I mean, we can have longer crop seasons. We have different crop patterns. That's really positive for Sudan. But this is really risky if we don't operate the GERD. So we need to operate a GERD on a coordinated way. So we need a coordinated operation for GERD. So if we don't have a coordination of GERD, so we don't know how to operate our dams and how to store water in our dams and how to release water for the Jazeera scheme. So actually, if we don't have that kind of cooperation for the operation of GERD. So, I mean, really, we are going to lose all the Jazeera scheme. So we don't know how to operate, how to store, which the amount of water that coming to the scheme, and so on, and of course, for the operation of dams in general. So this is really, really critical for Sudan to have a real operation rules for the GERD. So the other thing about the damage on the scheme, we'll talk about the flood water. So then if the GERD passes, amount of water that Sinnar and Rosaris dams cannot pass, the scheme will really face serious damage. Because if you see the capacity of the Sinnar dams about 3 million, and the capacity of the Rosaris about 6 or 7 million, and then the capacity of GERD is about 74 million. So if these two dams cannot pass this amount of water, this real damage to the two dams of Sudan. The last thing also that we may, with talking about the probability that the risk of GERD failure, that's also related to the flood of water flooding, and that may damage our dams, which Sinnar and Buceris dams. So with this, I will conclude my presentation, and thank you for your attention.
Okay, thank you, Dr. Agil. That was excellent. If anybody hasn't been to the Jazeera scheme, it's a pretty amazing place to see the water management out there. Spent a bit of time wandering the Jazeera scheme. Thank you for that.
Okay.
Lots of questions, but we'll go on to Dr. Hani Suelam. If you could stop the sharing of your screen, Dr. Agil. And I'll introduce Dr. Hani. Dr. Hani Suelam is his primary disciplinary area of expertise is also water resource management. He has his degrees are, he's got his PhD is from RWTH in Aachen University in Germany, master's from Southampton University in the UK, and his bachelor's degree from Zagazig University in Egypt. Dr. Hani is currently employed, he's a professor and managing director for the UNESCO Chair in Water Resources Management at Aachen University in Germany. And when I asked him what his vision is for the Nile in 20 years, Dr. Hani said, a basin in which any future project is developed in full coordination with the other riparian countries for the benefit of the Nile people and not for the hegemony. And I'll have to say that that's almost identical to what Dr. Johannes said. Dr. Hani, please start your presentation. We're not hearing you yet.
Unmute my microphone. It's typical mistake. So thank you very much, Dr. Kevin Wheeler, for this nice introduction. I have to thank the organizers, UCLA, for having such a very rich and the patience also to organize such multi-week and couple of month seminars, which I think very good opportunity for us to come closer. And I also like to greet Dr. Bushara and Dr. Johannes. It's a great pleasure to meet you, Dr. Bushara, and also great to see Dr. Johannes again. I think we know each other very well. Also welcome all the audience hearing us, and would like to start. So the mandate of the organizers for me was very clear. We are here to speak about the current uses of the Nile water in Egypt, and my task is to focus on Egypt and potential implications of the Grand Ethiopian Renaissance Dam on Egypt, of course. So, maybe the numbers, they need to be put in a different way than what we heard from Dr. Johannes, who I have full appreciation to him. So let me see the Nile Basin from the Egyptian perspective. So the annual rainfall in the 11 Nile Basin countries is 7,000 PCM or billion cubic meter. So if we speak about only the basin itself, then we have 1,660 billion cubic meter of water. So of course we have sub-basins. I agree with him with what he presented. The water from Bahr al-Ghazal plateau is not really very effective because it's not contributing much to the water flowing to the downstream, but the equatorial plateau is contributing 29 to 30, 31 BCM or billion cubic meter of blue water. What's important to know about the Ethiopian plateau here, I'm not speaking about Ethiopia, the entire area of Ethiopia. I'm speaking only about the part in the Nile Basin. Here, Ethiopia is receiving at least 440 billion cubic meter of what we call green water or precipitation, and contributing to the flow of that's going to the downstream countries by 49 PCM, the blue water from the Blue Nile, and 11 PCM, the blue water from Atbara. So this is an overview, but here what we have to see as well, not only the blue water that has been shown by Dr. Johannes, we need to see also the green water. So you can see here the intensity of the rainfall in the Ethiopia. And of course, if you consider the food production, it's mainly agriculture, and we speak about rain-fed agriculture, then we are dealing with the rainfall mainly. It's not about irrigation only. Of course, there are some periods, as he correctly said, that you need supplementary irrigation, but most of the water that's required for irrigating your crops is coming from the rainfall. So Egypt is receiving, out of all what you heard, out of the 7,000, out of the 1,660, 55.5 as per the agreement with Sudan. This 55.5, 49 PCM is coming from the Blue Nile. Or you can say the 84 received by Egypt and Sudan, 49 out of it is coming from the Blue Nile. That shows the significance and the importance of the Blue Nile for Egypt. So this is measured at the location of the Grand Ethiopian Renaissance Dam. So it means that you are going to build a dam on the area or the river or the point that's bringing most of the water to Egypt. So that's why the dam is a very important project for us. So what is the situation of water in Egypt? So Egypt is a water scarce country. I think there is no doubt about it. The water share per capita reaching 570. I also wondered from the curve that my friend and my colleague, Dr. Johannes presented, that's only considering the blue water and not really taking the renewable water resources in Ethiopia. So the water poverty line in his curve is going to be looking completely different if you consider the amount of rainfall that is dropping on the country. So here I speak about in Egypt 570 cubic meter per capita per year. And this is, of course, far below the poverty line, which is 1,000 cubic meter. That makes Egypt recycle water and also import food in the form of virtual water. Fact is that Egypt is importing more than 60% of its food. Egypt's dependency on the Nile for its water, 97% of the water is coming from the Nile because the rainfall is very limited. Egypt is also desert. I mean, as you can see here, I don't have to speak. It's just a screenshot from Google Earth that shows you Egypt is desert. I mean, and with a very, very narrow area here about the green area that we are talking about, biggest irrigation area in Egypt. Of course, because there is no any other way to irrigate your crops. But you can see here the green coverage in Ethiopia. So what is important, I would really love that we collaborate together. But in order to come to collaboration, we need to put the numbers correct on the desk of the decision makers so that they really can come to both together and can really reach a collaboration. So the climate change in Egypt is adding more stress because we all know the temperature is increasing, the crop water requirements is increasing, the irrigation requirement is increasing, the industrial requirements, the domestic requirements. So climate change is going to put more burden on Egypt. So high salinity. We have here a new project that was just announced a couple of years. The groundwater is brackish groundwater. I'm not saying the entire country brackish, but there is also significant amount of salinity problem in the groundwater, and the rest is non-renewable water that's even used now and since years in the agriculture activities. So the agriculture sector is vital and important for Egypt, and this is important information so that we can also study the impact of the GERD on the job creation, when you know that 31% of the labor force is related or working in the agriculture sector, and 49% of them is female. So the water balance in Egypt, just to make it clear about numbers, 55.5 coming from the River Nile. The deep groundwater, the non-renewable groundwater, is used by 2.5 BCM. The rainfall is 1.3. If you compare this number to the rainfall in Ethiopia, is 936 billion cubic meter of rainfall is in the entire country. So desalination in 0.38, and this is increasing now. I'm going to come to it later on. Water resources in total is almost 60 BCM. Total reuse is 21.38. So the total amount of water is 81, and the rest, as I said, is compensated in the form of importing virtual water as food import from abroad. So the municipal, industrial, agriculture, evaporation, this is a balance so that you can see where is this water going mainly for agriculture, municipal uses, industrial, and part of it is evaporated in the network. So water poverty line here is about all these resources, especially the renewable ones, divided by the number of population. Then you have the water poverty line, 1,000 cubic meter per capita per year, and we are far below, and with the time the situation is getting more difficult. Now the responsibility of the government is to cover this green gap between the available water resources and the water poverty line, at least to survive. So what happened recently, changing modern irrigation systems partially to modern irrigation system, and this is a long-term project that's going to continue to change the traditional agriculture or the surface irrigation to modern irrigation, and you can read about it in the news. The government has already put a plan for lining 20,000 kilometers of canals. The Minister of Water Resources today announced completing 3,300 kilometers of the lined canals, plus the ones that already exist. I'm speaking only about the new project. Importing food more and more, reusing more and more water, agriculture and sewage water. So this was just launched a couple of months ago, the biggest water reuse or wastewater treatment station globally, and it's producing 5.6 million cubic meters per day. That's only this year, and very aggressively going to desalination, and all of that is just to cover the difference between the current uses or the current available water and the expectation of the population, or at least to reach the water poverty line. So coming here to the Ethiopian side, I just don't want to go in debate here, because we are here to come closer together and not really to start criticizing the numbers. And I have to say, this is one of the main reasons that the countries are not coming closer. Everyone is using the numbers in different way. But anyway, let us don't stress on this, but I just want to give you one number here, and I have my source, that the virtual water use, and this is the most conservative number you can find in the literature, is 75 billion cubic meter only for agriculture products in Ethiopia, which means that the rainwater or the rain-fed agriculture is producing as much as the water share of Egypt and Sudan. So we cannot ignore it by any means in order to really understand each other. The precipitation in Egypt here, you can see 18.1. I have here my sources, Aquastat, FAO 2018. This is the latest number I can find. And you can see here how many hundreds. And renewable groundwater, we didn't hear anything today in the statistics about the renewable groundwater. This is the most conservative number. You have some Ethiopian authors and publications are talking about 40 billion cubic meter renewable groundwater. So the numbers are here and the numbers are available, and you can check them. But let us come to the topic that's adding more burden on Egyptian side, including the government and the people of Egypt. So this is the River Nile, and you have the High Aswan Dam. You have the 3 dams in Sudan that are related to the topic, because here we are speaking about the main Nile and the Blue Nile. Now Ethiopia is building the Grand Ethiopian Renaissance Dam here very close to Roseras, and this is also one important issue in understanding each other, the distance between the Roseras and the GERD. So now you are adding one new dam to the system, and you need to fill the dam. If we have enough water in the system, there's no problem, and no one is going to. And Egypt signed the DOB, or the Declaration of Principles, in order to help Ethiopia to finish the dam and to continue and fill the dam. And that's what's written in the DOB. So the understanding of the need of the Ethiopian people for hydropower is clear to all of us. We all understand it. We all want to support Ethiopia to generate hydropower for the sake or for helping the people to have electricity. There's no doubt about it. So now to fill this dam during average, especially during the dry period or the prolonged dry period, then it means reducing the amount of water reaching the last person or the last dam in the system. So here, when you fill this dam during the drought or the prolonged drought, you expect dropping in the High Aswan Dam level. And dropping the High Aswan Dam level means losing electricity and having water shortage in Egypt, in addition to what I described about the very stretched and very stressful situation of water resources. So now, the more difficult part, because there is a discussion about agreeing on the filling, and that's enough for now. The long-term operation and the prolonged drought is more difficult and more dangerous than the first filling. Because if you have a prolonged drought, there is nothing in Egypt to offer Ethiopia. And then when the water comes after a long drought, everyone lost its storage. And when the water is coming after this very long drought, who's going to fill first? And this situation has to be agreed and signed. That's why the people talked about prolonged drought, binding agreement, commitment, etc., etc. So we are speaking about 3 issues here: filling, operation, and refilling. These are the things that we need to agree upon. We have been failing to agree between the 3 countries for a very long time now. I'm not going to go through this negotiation marathon because for the objective of today, but Egypt has tried every possible option in order to reach an agreement on the filling and operation. But let us come to what is needed to be clear to everyone here: the socio-economic and environmental impact of the GERD. The panic of the dam itself and the dam safety, it's still a big question now. I'm not criticizing the dam or the safety measures of the dam. I'm just speaking about facts. And these facts are causing very stress and panic in the Egyptian society. And this is a social impact that has to be taken into consideration. Where are the detailed design of this dam? Why it's not published? Where is the socio-economical impacts of the dam? Where is the studies for the environmental impacts of the dam? Nothing even at the governmental and the official level is communicated. And that's really adding a lot of stress in the Egyptian society. You can see here just one example for indicators from outside the dam, just what you can see in a normal picture. In 2019, you have 8 openings for the turbines, and in 2020, a year later, you have only 5. So you change the design of the system, design of a huge dam while you are constructing it. What's really adding stress and adding a lot of panic in the Egyptian society, and I'm sure the Sudanese society, but I'm not here to speak about my friends and my brothers in Sudan. So the methodology to determine the socio-economic and environmental impact, which is a study that has been done by very well-known international consultancy, which is Deltares, is based on filling and operation scenarios. What are the different scenarios that can be used? Developing an impact tree, connecting the physical impact of the dam to the socio-economical indicators in Egypt mainly. Integrated simulation models, including water quality modeling, hydrological modeling, etc. Socioeconomic evaluation and also environmental assessment has been carried out using different indicators to measure the impact of each scenario. And then finally, having a scenario assessment to see in which case what will happen in Egypt in general. So this is the tree. Of course, I don't have the time to go through all these details, but it shows you here the relation between the filling and operation and the impact of the dam, physical impact about the water level, the quantities, the release time, etc., etc. Also the quality of the water, the oxygen, dissolved oxygen in the water, and other indicators. Here you have the process, you have the impact, you have process, you have impact, aggregating it and taking it finally to Egypt to see what would be the impact of water quantity, water quality on the socio-economical aspects in Egypt. So these are just some of the models that have been used in this study. I'm also not going to go in details. I'm not even socio-economist to explain you many of these issues, but I just want to set the credibility of this study. So the final, very, very short conclusion for the audience to understand is the impact of reducing or cutting the water reaching Egypt by 1 billion cubic meter. This is going to affect 130 hectares of cultivated land will be lost due to the missing physical water in irrigation, 430 million US dollar of agriculture production, $150 million increase in the food import to substitute what you missed already in the agriculture sector, and 290 people will be losing their income. Of course, we are speaking about farmers and the families of the farmers, and everyone is dependent on the agriculture process or anything that's related to the water that's physically lost through the filling and long-term operation. So this is the worst case when you fill the dam in the prolonged drought. If you take here the period of 1978 and take it up to the 2002, this period, and then you try to fill the dam. Here is orange color is the Grand Ethiopian Renaissance Dam, and the blue color is the High Aswan Dam. You can see here when you start filling the Grand Ethiopian Renaissance Dam, you have drop in the water quantity and the level of the High Aswan Dam. Then you have here the line of shutdown electricity, because you are targeting generating hydropower in Ethiopia, but you have almost to think that Egypt, to help Ethiopia to fill its dam, it's going to lose a lot of hydropower. It's going to lose also money for associated or related to this one. In addition, and the more dangerous than the hydropower is the quantity of water and the years that Egypt will not have water to supply and satisfy the expectations or satisfy the population with the required water resources as expected. So here, if we take this case, then Egypt will have deficit of 123. I have to mention here that this is including also the deficit that could happen without the GERD and the deficit that happens with the GERD. So adding both of them will give us more than 120 billion cubic meter over the entire period. And also this is the amount that will be average hydropower generating, which is showing that Egypt could lose up to 75% of the hydropower of High Aswan Dam. That's part of the impact, but you can of course multiply the 123 billion cubic meter with the indicators, with the quantities that I mentioned before. I didn't do this exercise, but you will see the huge impact that could happen in such a unilateral filling of the Grand Ethiopian Renaissance Dam without agreement with Egypt. And in this simulation, we followed the announced filling table from the brothers in Ethiopia. And here we did not consider, of course, the climate change, because Ethiopia is not an exception. Ethiopia is going to face a climate change. The entire Nile Basin is going to face climate change. And unfortunately, some of the studies or many of the studies are showing that the frequency of drought is going to hit more and more, and the hydrological extremes are already started. And we all see some of these examples. So to conclude here, the environmental impacts on Egypt there will be flow reduction, and this flow reduction will increase the salinity in the delta, will increase the salt water intrusion in the north coast of Egypt due to the depletion of the groundwater. That the salinity increased in this report estimated to be up to 31% increase in the salinity, which is a huge number. That here you have to also relate this to the agricultural productivity, because the more salt you have in the soil, the less ability for the crop to absorb the water from the soil, and the less final product you get from the agricultural process. So you have to relate things to each other. Moving from the precision agriculture to irrigated agriculture in Sudan, which we always count the good impact of the GERD on Sudan, this will move from precision agriculture to irrigated agriculture in Sudan. Most probably that's going to happen. And this will increase also the usage of pesticides, herbicides, fertilizers, which is going to impact the water quality that's coming to Egypt, and also going to impact the agriculture process and the soil of our brothers in Sudan. So lowering the dissolved oxygen concentration could happen, especially during the filling period, due to the organic matters that are already available in the lake upstream, but this is not going to be significant after the filling period. Changing the quality and the level of water in the northern lakes, of course, due to the water shortage, the northern lake in Egypt will be suffering from the quality of water received, with more salinity, with less quantity of recharging such lakes, and also changing the river ecosystem in the entire basin. So what we need to finish, what we need is to secure the water resources of the downstream, at the same time enable our brothers in Ethiopia to generate hydropower. If this is the objective of the dam, I personally see it very doable. I advise everyone to read the latest publication, not to any Egyptian guy, but to Dr. Kevin Wheeler. Please read his publication in the Nature last year about how these countries can come closer together. I think this is a very good base to reach a good collaboration between the countries. I thank him for doing this effort, really to put things on paper, to make it available for everyone, scientists, not only scientists. The paper is very well written, and I advise everyone really to read it. So Egypt has tried a lot. I'm not going to go on the details and how many proposals and options for filling and operation, but didn't work. So my advice to my colleagues, cooperation is not just a word. Cooperation is, have to show, you have to put the right numbers in front of the decision makers to be able to come together. I wish everyone in Ethiopia in this very difficult situation all the best, all the luck from my heart. I would love really to see a great country, strong country, to be able to collaborate, and the opportunities are enormous. There is an opportunity to have a common grid between Egypt, Sudan, and Ethiopia, not only the three, the entire countries. Egypt has launched this navigation project throughout the Nile from Lake Victoria up to Alexandria. So let us really think of a good collaboration, but please let us put the right numbers in front of the decision makers. Thank you very much.
Excellent. Thank you, Dr. Hani. That was a great overview, and I appreciate the noting my articles in there as well. Everybody here has published some excellent articles that I encourage people to read. There's a wide variety of quality of articles, but the authors or the people on this panel have all contributed substantially to the high quality literature coming from the Nile. We have a number of excellent questions. Some are more than we're going to have time to go through for sure. So I apologize for those that don't get their questions addressed here. But I mean, overall, we see a very there seems to be much more middle ground than is often shown in the press. There's a lot of talk of cooperation and coordination, and I think that's what typically everybody sort of wants. So maybe one of the first questions we'll put out to Dr. Johannes. wondering why Ethiopia, and this is, I'm using someone else's question, why would Ethiopia not agree to multi-dam operation, including the Had and the Sudanese reservoirs? What would be the challenges to that, and why is that not on the table? Or is it on the table, I guess?
Thank you, Kevin. So I think maybe the question is specifically on GERD during this negotiation phase, or generally why Ethiopia does not agree on coordinated mechanism between the two dams. If we are talking about in general, Ethiopia is not against the coordinated operation of the dam. Ethiopia just would like to have the proper ways of having coordinated mechanism. For example, some of the options that we put forth by Egypt during these negotiations are not really a win-win solution, and they were not acceptable for Ethiopia. But again, I don't want to get into the details of that. But generally, Ethiopia Ethiopia actually champions coordinated operation. In fact, if you remember back early phases of the Nile Basin, of course, there was a project called Joint Multipurpose Project before GERD. That project is one of the large dams in Ethiopia, which was planned to be coordinated within among the three countries. But Egypt left the table back then. But Ethiopia and as well as Sudan were committed into having a coordinated operation, as long as there is a proper mechanism to do that, or a proper way of doing that. So I think outside of this negotiation, of course, Ethiopia is always willing, but within the frame of this negotiation, I don't want to get into details, but Ethiopia has offered the maximum flexibility in order to cooperate with the downstream countries in terms of flood management. However, the requested, the counter offer from the downstream countries were not acceptable. Thanks.
Okay. Yeah, and I've been following as well. I know the different offers that both countries have made in terms of coordination. Now, maybe I'll turn to Sudan. There's a lot of questions that come around about the safety issues of the dam of being a significant concern. The question would be, what is the critical information needed from Sudan? What information does Sudan need to feel assured that the GERD would not cause harm? What information would be required that would help Sudan feel assured that the GERD will not harm Sudan? That's Dr. Agil, of course. Your mute is on right now.
Yeah, okay, hello everybody. Yeah, the information, I mean, as you said, the an issue of safety. I think that was a long discussion between the three countries. We don't want to talk about that, but we really need, as I mentioned in the presentation, we need a coordinated operation of the GERD when the water is stored and when they release the water. And it would be good if we have like a joint committee from Sudan and Egypt and Ethiopia for the operation of the GERD. So just then we need to exchange the immediate information. So because we have about less than 100 kilometers from the GERD and Roseris. So we need a real data in semi or in real time from the GERD to Roseris, and from Roseris to Sinnar and to further downstream. So we really need the information about the release from the GERD. Of course, the dam safety also is an important issue and really critical for the Sudan. So if there is a probability of the dam failure, so it will wash Sudan completely.
Okay, excellent. Thank you, Dr. Agil. And I would add to that, I work on a lot of different reservoirs, and one of the key pieces is that the downstream country has a forecast of what the upstream country is going to release over the next 10 days, over a period of time, communicating. So the downstream dams can plan based on what the upstream dams are going to do. So it's not just measurement, but it's also the knowledge to plan ahead over short periods of time to be able to.
Yeah, of course.
That'll be critical for the Rosaires Dam for the operations. One question to Dr. Hani. Well, there was a lot of conversation about green water versus blue water, and I'll just paraphrase this. There's a response about a lot of it has to do with the timing of the rainfall and the timing of the rainfall not necessarily being accessible for the crops. The question for Dr. Hani from this question is, can you comment on a cooperation between the three countries to store runoff in the cool Ethiopian highlands rather than the Aswan Dam, which has a high evaporation rate? Do you see that as a beneficial solution for all?
Now we are not speaking about the green water or the blue water. We are speaking about the dam store the water in the upstream or in the downstream. If this is a question.
Yeah. There was two parts to that. One was sort of a response saying just more the value of the upstream dams basically for retiming the water. But this question, the question more directly is about storing upstream to minimize evaporation in the system as a whole. Okay.
So I shared a screen here so that we can make it visually clear to everyone in the room, especially the one who asked it, who I asked. I thank him for the question. So these are the different crops I asked my students to put all of them on one graph. These are the crops that commonly grow in Ethiopia, especially here talking about the Blue Nile, as it's a topic for our, and here is the tendency of the rainfall in average. And you can see here, I understand you need to store water here because the crop water requirement is not covered during part of the year if you are interested to grow 2 seasons in Ethiopia. So if you want to have a reliable water source to grow crops, not only 1 season during the summer, you need to store the water. So there will be a problem here. And of course, if you have here a drought period of a couple of weeks, would affect the productivity of your crops. So you need to have access to water during the drought period. And here we have to think about the groundwater. And the groundwater here in Ethiopia, this is one of the interesting publications, one of many actually, that shows here in the Blue Nile, the potential for groundwater. Because this rain, it does not disappear as sometimes we hear. There is a water balance that we need to understand. So there is a water evapotranspiration map. You can see here, there is a rainfall map. There is a groundwater storage that you can see here distributed. So groundwater is available in Ethiopia and renewable. And we need to see that if we are really looking for solutions that bring the countries together. Let us think on collaboration together on using the groundwater here. So you have at a very shallow level, you have a groundwater in the Blue Nile. And let me put the Blue Nile scheme here so that you can see what I'm talking about. This is a very shallow area that you can see. You can see the agriculture, the rain-fed agriculture is here. You can see also the groundwater storage. So there is available groundwater. And the conclusion of this study is saying there are more than 2.1 million hectares could be irrigated using groundwater. This is for me storage of water that's happening naturally that we have to study it more. I'm not saying just go and dig well and start. Let us work, let us collaborate together on using such water. Coming to the issue of storing in the upstream in the GERD instead of storing in the HAD, let me put the question very clear to everyone. So the debate is if you store the water in GERD and reduce the storage of HAD, then you have less evaporation. Let me correct this statement a little bit. when you store the water in the upstream after the GERD, first of all, if you don't have a binding agreement that's committing Ethiopia to release water whenever needed in the downstream, let me tell you, it's not one country. Unfortunately, could have loved to live in this kind of world, that to have access to the water whenever you want, whenever you are struggling. But now imagine we have almost 10 years of marathon negotiation to reach at least the filling, and we are not able even to reach a common understanding. But technically speaking, you know, Dr. Wheeler, and you also indicated it in your paper, that when you regulate the flow in GERD, the Sudanese dams will be operated at a high level, which means there will be an additional evaporation happening in Sudan more than what's happening today. So we have to calculate the evaporation that's going to happen in the entire system before just making a conclusion that we can save water. And saving in the storage on the cost of what? The cost of energy in High Aswan Dam. Don't we have a price for this energy? If the objective of the GERD is to generate hydropower on the cost of HUD, then Egypt is willing to sacrifice part of this energy, but we have to consider it. We have to consider it in our calculations that this will be on the cost of hydropower in Egypt. Thank you.
Okay, thank you for that, Dr. Hani. That, yeah, I would agree with that. I think that it makes, from a physical point of view, it makes sense to store water up high, but that requires agreements on when and how to release that water to make sure it's always interesting to think if it were all one country, how would it be operated? And most likely we'd store water up higher, but with the guarantee that it would be released a certain quantity when it needs to be. Many other questions. We'll say to Ethiopia, to Dr. Johannes, what is the degree of responsibility to assure the safe operation of the GERD, safe operation and the communication of safety? What is the ethical responsibility? What is Ethiopia morally obligated to do in your opinion?
Thank you, Kevin. So regarding the safety, I think even the downstream countries have acknowledged, the Minister of Sudan has claimed that it's one of the safest dams in Africa. So the maximum care has been taken, and the downstream countries actually were involved in the different processes to make sure that the dam is 100% safe, both during construction and operation. So I think there is no issue regarding safety. But again, this question of safety is not really a question of safety. It's a question of making the operation less flexible for Ethiopia. The requests that were put forth by the downstream countries, that was the reason why it was difficult for Ethiopia to accommodate the costs. So safety in terms of, for example, how much water will be released, safety in terms of the fluctuation, the daily fluctuation, the monthly fluctuation, all the requests, pretty much all the requests that were asked by the downstream countries have been accommodated by the Ethiopians, and this has been confirmed by Sudan as well in the earlier phase of the negotiation. But later, again, the safety surfaced around because there might be other intentions for it. But I don't want to get into that. But Ethiopia has made sure that the dam is really safe, because Ethiopia is investing a lot of money on this project. So Ethiopia wants to make sure that it's safe, not even for forget about the downstream country, but for itself, for its own people. So I think there is no question regarding the safety of the dam. Thanks.
Yeah, and I would say that the dam safety issue, while it has come up significantly recently, it's one of those issues that seems like it could be addressed pretty easily with information, because it's not about is the dam accusations the dam is unsafe, but simply the lack of information sometimes on assuring, because, and of course, dams, they change through time, and making sure that they continue to be safe and they're being monitored. I think that's probably the biggest real concern, is just making sure that information is transparent, that allows confidence.
In addition to the information, I think the other key important thing is the downstream countries should also be willing to change their operation rule, because, for example, for Rosares, and it's talking about safety of Rosares, now that with GERD, the flow is going to be significantly regulated. So there is absolutely no need to operate Rosares or Sanar the way it used to be operated in the past. So there has to be willing to change some things, because the system is changing. They have to adapt to the new system to accommodate that. But insisting on Ethiopia accommodate every request from the downstream countries, sticking to the old mechanism operating the dam is slightly unfair to the Ethiopia side, I think. Thanks.
Yeah, I think that's a fair point, and I think Dr. Agil's center at the Hydraulic Research Center really does focus on how to reoperate the dams. They're very aware they need to reoperate the dams. Dr. Agil, can you talk at all about the coordination, or what is really what the HRC or what the ministry is doing in terms of thinking about operating their dams downstream?
Yeah, I think the Dr. Johan said that of course we need to have a new operation, so we don't have to follow the old operation of the dams, but we don't also need that the Ethiopia have to unilaterally operate the GERD. I mean, so if they operate it, then we have to know the total released flow when they will release, and then we need to operate that our dams accordingly with the minimum harm to Sudan. So they may operate with the maximum benefit for Ethiopia, but they may harm Sudan. So with the coordinated and with the cooperation between the two countries, then we will have benefits of the two countries based on the operation of GERD and the new operation of Rosares and Sinar dams.
Thank you for that. I think we're getting close to being out of time, but I think we're even a little bit over. I'm going to ask one more question to Dr. Hani. There was a question often about salinity, and I'll try to paraphrase this a little bit. Isn't the GERD? Let's see here. How does the GERD impact salinity in Egypt? But isn't the cause of the salinity more attributed to the entire cascade of dams and the water use rather than the GERD itself?
The salinity issue is more complicated than just being a simple issue that reducing the water in the system is going to increase the salinity. But the drought measures that everyone is talking about, the drought policy measures, or the drought policy is going to, or invoking a drought policy in Egypt, is going to impact the salinity of the soil, definitely, and also the salinity of the groundwater. And if you want me to describe them technically, moving from surface irrigation to drip irrigation, what the government's doing anyway, is going to reduce the amount of leaching or washing the soil that's normally already in the surface water, and even adding it to the soil will never wash the soil as the surface irrigation. This is one thing that contributes in the increasing the salinity in the soil, especially in the top layers of the soil. The second issue, once you minimize the irrigation requirements and you just give it using drip irrigation, there is no recharge of the aquifer. So if you don't have recharge of the aquifer and you have people are over pumping everywhere for using the groundwater for irrigation, the groundwater level will be depleting in the north coast of Egypt, and there will be a saltwater intrusion or seawater intrusion that's happening from this depletion that happens in the groundwater and add to that the climate change and the sea level rise. So two different levels of water going in two opposite directions. The groundwater is not recharged, and over pumping is going to be depleting. And of course, every time you speak about invoking the drought policy measure, you have to think about all these details that it should be considered, and one of them the salinity.
Thank you. That's excellent. Salinity is a major challenge, and it's a long-term challenge. River basins around the world have faced salinity. If you fly over the Tigris and Euphrates, the salinity challenges there are enormous, and they're long-term. They will be something that Egypt will struggle with for a long time, especially as they become more efficient with their water. That does reduce the amount of water to flush out to the sea. So I think that's all the time we have. If I'm not correct, Makonnen, I will hand this back over to you if that's true.
Okay, this is Professor Keller, and I'm going to wrap this session up. I want to thank our presenters and also the moderator for an excellent discussion of this very important issue. This whole webinar hinges on this discussion that was brought to a head today. And it sets the stage for where we're going after the new year. We were lucky to have Dr. Weaver with us as the moderator, and he'll have a lot more to say when he hits the stage again in January. I want to personally commend the presenters, Dr. Johannes Gabriel Sadiq, Dr. Angel Bushara, and Dr. Hani Suwilam for their excellent presentations. It was done in a very civil manner, which is good, because that's where we want to end up. Our last session is going to be a frank discussion about the way ahead, long-term management operations. But next session will be on December 8th, and that's going to feature Dr. Anna Elsa Casido, and she will make a presentation entitled "The Nile Flows Towards the Red Sea and Not the Mediterranean," which is going to be very provocative, I'm sure. For those of you who are taking a break for the Thanksgiving holiday, enjoy. And we will see you next time on December 8th for Dr. Castillo. Thanks very much. Have a good day. Thank you.
Thank you very much.
All right.
Thank you, everyone. Thank you, Kevin.
Okay.